Hello. This is my first video, and I just want to talk about a recent mini project I've been working on, which is essentially to make a simulation of a CPU. Just a basic idea, like the basics, the memory, the register, the program counter, the zero flag, all those little stuff, and just getting a more like intuitive understanding of what a CPU is and what it does. I'm a CS student, freshman, and what I want to do with this channel or with these videos I hope to be producing is to just have a space for me to like express my passion, not even passion per se, but more accurately my philosophy I'm developing as I continue to learn about CS. Because believe it or not, CS is actually an art, or at least in the idea that there's a lot of interesting little nuances in the stylistic choices you might make with a program solution or in the choices of constraints you have to work with. And on some intuitive levels, you can feel like there's a very respectable amount of beauty hidden within that. And this is just my outlet to express that interest and also learn and hopefully just have fun. I'm gonna give a basic rundown of what this project does and what some of my future goals for this um, channel will be. So basically, this is just the header file for a basic CPU struct, which is just a simulation of a CPU. Um, it has the memory, 256 bytes. It has 4 registers, and for context, a register is essentially just a mini place for us to quickly store information during an operation that we can then either move to storage or memory or use it for a future operation. The program flag serves more as a counter as to where the program, where think of it as like a little indicator of like what the next instruction might be. Although I have read some CPU designs might use it as an indicator for where you should be in memory, but I digress. And the zero flag is just a quick operation we do to indicate, oh no, was our last operation just one? The stops halted. This is just like it's a little node to tell us like when we're done running the programs that we loaded into our memory. So, oh my bad. So this is just my basic sort of functions to initialize the CPU struct. You copy in the memory, reserve it, reserve basically everything to an empty state. This is the set zero flag. Essentially what we do is just an automatic check to see if our last value was zero. And if so, just put one to indicate that, oh shoot, there was a zero. So like in C anyway, one is representative of two, because like if it's zero, it's like false, nothing was activated, and if it's one, something was activated and is equivalent to being true. The reason why I mentioned that is it took me like a few weeks to figure that out. So pretty cool thing about C. Then with the CPU load program, essentially what we do is we just we load our program or instructions for the program into the CPU. And one interesting thing I saw was this memory where we're loading our programming instructions is the same memory section where we have to store information typically. So one question I've been having for CPU is how exactly do you define the buffer between program instructions or stuff we're storing for the program? Because let's say I want to store something as like the first or third um, byte in the memory. Oh no, I have a program instruction there. And if I want to store it further away, how do I know how further away further away in the memory I should go? So that's low-key something I would love to work on for the next iteration of the CPU simulator. Then this is the CPU step. Essentially, what it does is it takes the instructions for the CPU, or like in the program, and it breaks it into two parts: the OP code and the argument. Well, operation code essentially, which essentially tells the CPU what we should do. And for context, um, the CPU instruction is a singular byte, with 4 bits being the operation code and 4 bits being the arguments. That's why we have like the bitwise operation to push it forward to the right. So let's say I have something like 0x5f 002. Those that 4 would just like add 4 zeros here and just remove this, and just the only relevant information will be this, which is pretty cool. And this essentially is a bit mask. Interesting thing about the bit mask is it just essentially just tells a program which bits are relevant. So we just say like, and for 0x05f, it's 0001111. So only the values in the second half of the byte would be relevant. Then we use register 1 and register 2, which are just like the first two bits in the argument, and the last 2 bits in the argument. Now, something interesting I want to note is there are certain like registers. For context, this CPU design has 4 registers. There are certain operations where you won't be able to move a byte directly from a register and into memory, because the value is going to be slightly off, and that's relatively interesting. I really do want to work on understanding how people bypass this, or why not actually just increase the size of your arguments to like 2 bytes instead of 1 byte. So, instructions to 2 bytes instead of 1 byte. So that's a pretty cool thing. And essentially, what the CPU step does is it figures out which one of the operation codes you were given in the program, and then it will do the following operation. In the case of for anyone who's unfamiliar with what this might be, essentially what this says is like the 0x0 is just saying that, oh, this is 1. This is the first operation. This is our second. This is our 0th operation. This is our first, second, third, fourth, fifth, etc. So essentially just saying that we're essentially just saying like, do operation 1, do operation 2, or something else of that nature, and we'll use the argument and the register we generated from it in order to do the operation. This actually brings me to the register header file, which just shows like, it's a basic enum for an assembly language I plan to make eventually, because low-key typing out each operation code and then figuring out the right number is kind of a pain. So I would love to automate that, or at least add a layer of abstraction. So yeah, this is just loading a bit into a register, adding, subtracting, moving values between registers, loading a value from memory onto the register, storing a value onto the memory of the CPU, halting it, as in like stopping the program operations, jump, as in like, let me double check, but I'm pretty sure it's just moving. Yeah, it's just moving the program counter all the way to a different argument. Yeah. And something interesting is the jump is the JZ. Essentially, what it's saying is jump if or if one of our values, if our zero flag is one. So if there's a zero in the previous operation, then jump, which is pretty cool. This is just a CPU dump, which essentially just I just made it to get a good idea of what exactly was being stored in the CPU struct. Uh, one interesting fact is you would think that since we have 4 bytes and we're printing out like the initial instructions, it would take 4 characters to print it out, 4 bytes to print out. But funnily enough, it takes only 2 bytes. And my guess is it's not actually 2 bytes, but just two somebody singing in the hallway. Yeah. In reality, it's just it's not it's not 2 bits. It's just 2 bytes. Because of what because when in regards to what the memory is putting in, we're putting in bits, not necessarily bytes. So after we put in the full instructions, or at least memory copy the program, the first value we're going to copy is going to be one of those instructions, and then adding a secondary value as the argument, and that essentially serves as 2 bytes, funnily enough. I'll show you what I mean by printing it. But essentially, what essentially happens here is we initiate the CPU. I then like set the first register to 5, halt the program, and then run it. And then I'm pretty sure we add 1. No, we add 5 to the second one. What we end up doing here is I'm pretty sure we add. Oh, we actually move a value from. Oh yeah, we move a value from register 1. We copy the value or we move it. It's more like copying in this program rather than moving, because we're not deleting what was in the last register. We're just like copying it over into a different register. And this is essentially just copying the value in register 1 and putting that value into register 2. I'll show you what I mean in a second. Yeah. Oh yeah, the Git file is also public if anyone wants to look at what I did, so that's cool. So make CPU test. So yeah, we see the register is pretty much empty. We then move a value to 5. We then copy a value to not the second register, but into the 0th register, the first register, and then we proceed to add 5 to the register again. And then, fun fact, I'm pretty sure I was aiming to copy that value copy the value in the second register into memory, which I do actually. What ends up happening though is right now it's set to print the first value in memory after the program. So yeah, you're not going to see what exactly is in there. But I digress. So basically, that's my CPU simulation. I do plan to go a bit more in depth, expanding this project to include an assembly language too, and just better model what a CPU is and does, especially in C. As you can tell, this is more of general beginning project meant to evolve as time goes on. And this is more of a side passion because I honestly wasn't expecting to spend I think 4 to 5 hours creating this last night and this morning, and it was rather fun. So, yeah. In regards to what I want to do moving forward with this project, I was thinking I previously said it would be more of a expression of my interest in the philosophy of computer science, as well as some programming projects. That's true. I also want to make the extra note. I'm going to try to not vibe code the project. I will bluntly be using AI on some level to ask her, hey, um, could you explain what am I getting wrong with this mental model? What my CPU is doing? What's the point of this register? Um, how do we determine the right instruction sets for our CPU or stuff like that? So I won't do Claude code produce me a CPU or something of that nature. But I want to be honest in the fact that I will use it on some level as both a mentor and getting some level of feedback on where the direction of the projects might be going. So yeah, um, stick around. Thank you for listening to me, and have a wonderful rest of your day.